In this video, I'll be going over some additional information about type annotations. As you know, type annotations are required in function signatures. Usually, types are inferred by the Rust compiler. However, you are able to specify types in certain locations. When you do so, this is called explicit type annotation. Here's an example. At the top, we have a function which has type annotations. This entire part is called the function signature, and within the signature, we have two types. We have a string slice and a 32-bit integer. Functions are always required that we specify the type using these type annotations. Next, we have a mouse enumeration for use in the example down here. Next, we have a let binding with a variable called num. We then use the type annotations that are familiar from function signatures to specify that num is a 32-bit integer. Normally, we don't include this because the compiler is able to figure that out by looking at the data. It is useful, however, if you want to be sure that this is always an i32. If you were to set this number to a value that is too large to fit within an i32, then you would get a compiler error. Next, we have the variable a. It's being set to the character type, and here we have a character. Just as with the numbers, if you were to type a string here instead of a character, you would then get a compiler error because you told the compiler that, hey, this is supposed to be a character. Lastly, we have the left click variable. We're telling the compiler that it is a mouse type, which is here in enumeration. And we're just setting it to the left click variant of the mouse type. Again, this part is optional. There are some instances where it is required. When that happens, that usually means the Rust compiler was unable to figure out the type for your variable, and the error message will indicate to you that it could not figure this out and you should provide a type. When that happens, that's when you'll need to specify the type annotation. Here's an example using generics. So a vector is what is called a generic data type. It's a data type that contains other types, and it can contain any other type. Normally, when you're making a vector, you can just use the macro as such and specify the information within, and the compiler can figure out that it's a vector of i32s. If, however, you want to store a vector in a structure, you will then need to know how to specify the signature. When creating a vector, you can specify the type of items within the vector using the less than and greater than symbols. In the letters variable, we're creating a vector of character. And as we can see, we have our characters here. And then for the clicks variable, we are creating a vector of mouse, which is the enumeration we saw on the previous slide. We have three elements of type mouse, a left click, and then a right click. Again, the compiler is able to figure this out most of the time. Occasionally it needs some help, so you would need to specify it. It is required, though, to specify the exact type when using a structure. To recap, type annotations are mostly optional within function bodies. Occasionally, they are required if the compiler cannot infer the type. When this happens, the compiler will inform you that it was unable to infer the type, and you'll have to manually specify using type annotations. You can also optionally specify type annotations when using let bindings. However, it's usually easier to just let the compiler figure it out.